Hello everyone. In this video, I will present the survey paper, Report Collection, a survey on detection, isolation, and identification by Heldian, DeLuca, Schaeffer. This is not just a simple review, it's a survey that also includes theoretical analysis and experiments, mainly on the DLR-KUKA lightweight robots. I will first summarize the main idea and then critically evaluate the strengths and weaknesses of the paper from a research method perspective. The motivations of this paper. Why robot collision handlings? Robot now share workspace with the human in industry, survey area, and home staff. Need to limit human injuries and protect the robot. Focusing on censoring not external camera or skins. The main research topic of this paper is how to detect, isolate, and identify robot collision in the real time using only internet sensors. The conceptual contribution is the collision event pipeline. We can see 7 steps: pre-collision phase, collision detection, collision isolation, collision identification, collision classification, collision reaction, and finally is post-collision phase. Conceptual contribution is the collision event pipeline. We can see 7 steps: pre-collision phase, collision detection, collision isolation, collision identification, collision classification, collision reaction, and finally is post-collision phase. The author argue that safe interaction is a process, not just a single detection step. They define verify 7 phases, but the paper concentrate on the phase 2 to phase 4 detection, isolation, and identification. This pipeline also structure the lectures and show where different methods fit, which is helpful both scientifically and practically. So, let's talk about robot models and monitoring signal. The paper first review rigid joint robot dynamics and then extend to flexible joint robot. From the models, they divide physically meaningful quantity like total energies and generalized momentum. Our collision monitoring method basically trying to construct a residual signal mu that react strongly to collision but remain close to zero during normal operation. Later, the other compare different wave or baiting mu. From simple torque, here is torque is a kind of spinning. It's a threshold to more sophisticated momentum observed. The next slide is survey or collision monitoring method. The paper systematically reviewed several families of methods. The industrial approach are simple threshold on torque or torque change. They are cheap but not very informative. The motor-based method use the robot dynamics more deeply and can, in principle, provide not only detection but also localization and full estimation. A large part of survey evaluate the method along several dimensions such as computational effort, required measurement, to modeling errors, and how well they support the different stage or collection pipeline, to extension, flexible joints, and experiments. The survey does not stop at the ideal rigid robot. It extends the momentum-based approach to flexible joint, which is realistic for lightweight, torque control arms. The other conduct experiment with DLR, KUKA, LWR, colliding with a crash test, driving her at around 2 meters per second, showed that because of structural flexibility, torque sensor and observer see the impact with a delay. So the threshold must be NAM0 to avoid false positive. They also demonstrate that A simple energy store trigger by the observer can reduce the collision duration to a few hundred milliseconds. Here are the standpoints of the survey paper. If we consider research topic and general problem, is highly relevant and timely. PXRI safety is the share was paid. After that, we consider about the selections of the keyword. It cover both industrial, heuristic, and academic model-based method. And for the lecture review method, its kinds are narrative, organized sentences, not just a list or paper, robot dynamic and where observed observer theories, and validation key method, especially moment observer with simulation and real experiment on a well-known robot platform. For the presentation and conclusions, it's very structured. The 7 steps of the pipeline, model method, flexible extension, experiments, and conclusion is quite good. Good use of figure and comparison table are really suitable to understand. Conclusions are consistent with both theory and experimental evidence. On the other hand, if we discuss about the weakness and limitations, focus on salary is logical, but it means the survey multi-molded approach that combine versions, skin, or machine learning, which are increasingly important. The selection of the keyword is broad but not systematic in the straight academic sense. There is no described such protocol or bias assessment, so some approach may be underrepresented. The experiments are converting but restricted to one main robot platform, and the evaluation is more qualitative than statistical. Finally, this paper is mathematically dense and strongly centered on the moment observer family, which might observe other promising trends in collision handling. As an overall conclusion of this paper, it's by comparison industrial heuristic and model-based observe, it showed that generalized momentum-based method offer the best. As a final, the paper is a strong influence survey for collision handling and a solid foundation for the future work that combine multi-sensor, data-driven method, and formal safety evaluations. Thank you for watching to the end.